Okay, good evening everybody. Okay, in this video we will look at the steps in drawing the ray diagrams for mirrors. Okay, to locate the image formed by a mirror using ray diagrams. Okay, now what we have here is we actually have a particular scenario. Okay, so I will have actually a mirror here, and I will have an object that is placed in front of the mirror, and I have an eye here. So the question usually will tell you to actually use ray drawing diagrams to draw rays to actually shows how the eye actually capture the object O from the mirror. Okay, so what you are going to do is, like I mentioned before in the video, ray drawing diagram for mirror is a bit reverse engineering. Okay, which means that you actually know where is the image already. So what you are going to do is you are actually going to identify the outcome first, the image, locate the image using the properties of the image. Then after that, what you are going to do is you are going to fit in the ray drawing diagrams, the rays, according to the law of reflection. Okay, the property of ray or the image that we are looking for is the distance of the object in front of the mirror is exactly the same distance as the image behind the mirror. That is the property that we are using. That property actually allows us to identify the location of the image itself. For example, the image that I have here. Okay, let me use a red pen. Okay, the red pen will denote my working. Now you'll find that the object is in front of the mirror. The object is in front of the mirror. So what I do now is I will actually measure the object. For this case, it will be 4.1 cm. So what I'm going to do now is I will actually measure 4.1 cm here. Okay, and this will be actually the location of my image here. So this I will label it as I. So before you do any working, you actually got your answer already, because from the property of image, I actually know that, okay, the distance here, the object distance, okay, I will call it D1, is actually the same as the image distance, okay, from the mirror. This distance I will call it D2. This 2 is exactly the same. Okay, so what you are going to do now is you actually use the property of the image to actually locate your answer already. So the next step you are going to do is you're going to fit in the ray drawing diagrams. Ray drawing diagram, okay, as we mentioned before, your eye supposedly, okay, is able to see the image of the object. So your eye is actually able to see this eye here, the image here. So what you are going to do is your eye actually perceive that light ray come from the image itself. Because you are able to see the image. So you're actually going to see the light ray here, okay, from this side all the way here. But we do know that anything behind the mirror is virtual, which means it doesn't exist. It's a makeup because of mathematics. So which means the light ray that you see, it enter your eye, okay, your brain will perceive that it comes from the image. But actually this perception is actually not true. So what we're going to do is we're going to denote it by dotted line, virtual rays. So this is the dotted line. So what you're going to do is this is actually a straight line, your ray. Okay, your eye actually perceive that you actually see the image, and your ray actually come from the image. Your eye actually believe that what he's seeing the image is actually here. So this is actually a ray that comes from the eye and enter your eye, and it fits the property of light ray. It's actually light ray actually come from a source and it's travel in straight line. Okay, so at the intersection point of the mirror here, you actually know that this light ray actually come from the source. So from the mirror, okay, you are actually going to trace back the image or trace back the ray to the source itself. Okay, so you will know that the light ray actually come from the object itself. So you will have the complete light ray or the true light ray that come from the object, hits the mirror, and it reflect and then enter your eye. Okay, so this will be the real ray that you see. The dotted line behind is the virtual ray that your brain tells your eye. Okay, that because your brain understands that light ray travel in a straight line. Okay, so that's why it perceives that this light ray actually comes from behind the mirror. That's why we actually give you a dotted line, okay, to symbolize virtual. So same as before, to locate this image, one ray is not good enough. So what you're going to do, you need actually minimally a pair of rays, 2 rays. So what you're going to do is you are going to repeat the same thing again, but now the light ray, same thing, your eye will receive the light ray from another part of the eyeball. So let's say your light ray will enter your eyeball at another location. Same thing, your eye or your brain will perceive light ray come from the image, travel in straight line. So you will here, anything behind the mirror is dotted line, okay, this way. Same thing at the intersection point of the mirror, you know this ray come from the source itself, so you are going to trace back. Okay, same thing, arrow. So now you have the second pair of light rays coming here. Okay, so the second set of light ray, okay, which come from the source itself. The source hits the mirror and enter your eye at different part of the eye. So you'll find that if you trace back these 2 rays, they will actually intersect and they will actually give you the image location. Okay, so what you do now, what you're doing here is you actually predetermine the image location using the property of the image itself. And from there you work back, you trace back, you reproduce the light rays, the necessary light rays to produce the image or to locate the image. And this is how we do ray drawing diagram for mirrors. Okay, so this is how we locate image of the objects, okay, for a mirror, okay, when mirrors is involved. Okay, so the step-by-step approach, I repeat again. Okay, first thing is to locate the D first, the distance, object distance, and the image distance from the mirror. Okay, so you will be able to locate the image first. After that, from the image, trace a straight line or trace a light ray back to a point, a part of your eye, of the eye. After that, that point of intersection on the mirror, trace it back to the object, and you will have a complete first ray. So what you're going to do now is you're going to repeat the 3 steps again. Okay, from the image, draw all the way to another part of the eye. That's the first step. Second step, locate the intersection point. After that, trace back to the source itself, and you will have the complete second ray that we are referring to. And this will be a complete ray drawing diagram for identifying the image formed by a mirror. Okay, so for this, okay, please remember the practice and to see how you can actually locate image for different parts of the object itself. For example, in this case, let's say I have another object, again the mirror here. So now what happened is I actually have a square object. Okay, so my eye will be here. So what you are going to do now is you are actually going to repeat the same process again. Okay, so now I'm actually going to measure the location, okay, of my square, of my object, to actually locate the image first. So example, this will be 3.8. Okay, so I will have this 3.8. Okay, so if you trace back, you'll find that this square is roughly here. Okay, so you'll find that this will be the image. Okay, pardon me, it should be dotted line here. Okay, so this will be the image form here. Okay, so this will be my object, this will be my image. Okay, take note, this has to be dotted line. Pardon me, it's dotted line. So what you're going to do is, how are you going to see the object itself? For 2D objects, so what you're going to do is you can just select a point. So I will do a fast one. Okay, so I will select this corner here. Okay, so I will repeat the process that I did for the first part. Okay, my eye will perceive that I actually see this corner. Okay, light ray actually come from here, but anything behind the mirror, it should be dotted, it should be virtual. So it will be dotted here. Okay, so anything in front, it will be real, the real ray. Okay, and you'll be entering my eye. Same thing, I look for the intersection. I know I uses this point, my eye actually perceive this part. So my light ray here actually comes from the same location here, the same corner here. So I will actually trace back here. So this will be the first ray. So what I'm going to do now is I'm going to repeat this again. I'm going to repeat it for the same corner. I'm going to repeat it at different location. Okay, so for the same corner, I will have the second ray here. Same thing at the intersection point, it should come from the same corner here. I'll put arrow here, I'll put arrow here. So I will have the first pair of ray for the first pair of corner. So for 2D, how do I know how big, how do I know where is the image? Okay, using the property of image, I actually can locate the image already because I know the image and the object is equal distance away from each other from the mirror. But for ray drawing diagram, how do I know that? From ray drawing diagram, you'll find that I can actually locate a corner using one pair of lines. So I can, if I need to locate the second corner, I need another pair of lines. If I need the third corner, I need another pair of lines. So if I'm looking at 4 corners, I'm easily looking at 8 ray diagrams. Okay, so now what I'm going to do is I'm going to show you how it looks like if I use 2 corners. Okay, it will looks a bit complicated, but it's actually repeating what I have taught, repeating for corners and corners. Okay, so here we go. Okay, take a look. Okay, now I have completed the second corner. Okay, let me zoom in first. Okay, take a look. I've completed the second corner with another pair of rays. The blue, the rays that I'm like using my blue pen. Okay, so you'll find that if you look at the eye or you look at objects like here, you'll find that you have a lot of lines crisscrossing. The blue one you have one pair, the red one you have one pair. When I enter the eye, I have another pair, a blue pair and a red pair. So you find that there's a lot of lines flying here on the object and the eye side. But if you look at it seriously, you'll find that all this line is, I don't draw all this line one shot. What I did is I actually do it ray by ray, point by point. So I look at this corner, the blue one, I draw the first ray first. Okay, like using the process I outlined before. Once I complete the first ray, I will look for the second ray. The second blue line I will draw again. So at any one time, what you're looking at is, what you're doing is you're actually drawing one ray only. Okay, despite having like 2 pairs of rays, you are actually drawing one ray at a time. It's just that the outcome for 2 pairs of rays, it will be slightly complicated. But we don't draw 2 pairs of rays straight away. It will be very, very confusing. So what we are doing here, we actually draw it ray by ray, one by one, each corner at a time. Okay, and with this is, I repeat again, this is the way of, or these are the steps of how you draw ray drawing diagrams for mirrors. Okay, to locate the image formed by a mirror. If you have any questions, okay, drop a comment or drop a question in the comments bar below. Okay, if not, okay, I hope you will take this video or you take these steps and practice these steps of drawing the image yourself. Okay, at least do it for 2 times so that you're familiar with the process and you are able to locate the image or draw the image or complete the image without any hiccups easily, like within 3 minutes or 2 minutes. Okay, because in exam your time is precious, so you do not want to spend a lot of times on your ray drawing. Okay, so ray drawing diagram, if you practice enough, you are well versed in it, you actually can complete a ray drawing diagram within 2 minutes and you can get the marks easily. Okay, so okay, please practice, okay, and enjoy. Okay, see you.